we have lots of ways that we can find areas, and kind of the main focus of this unit has been on finding and estimating areas under curves. If we have the curve being y equals 1/2 x, and we want to evaluate the area from 0 to 10 underneath that curve, it's not too bad once we recognize that this is just a right triangle. So we can use our area of a triangle formula to find that area, recognizing the area is 1/2 base times height. The base is the length from 0 over to 10, which is obviously 10. And then the height of our triangle is going to be the functional value at 10. So the height is going to be 1/2 x, which is 10. So 1/2 times 10 times half of 10, which is 5. Evaluating this, the area of the triangle is going to be 25. If we shift that interval from going from 0 to 10 to 2 to 10, now all of a sudden we have a trapezoid. And so we can see that right here. And the two vertical sides are going to be our parallel sides, so those are our bases. And remembering the formula for a trapezoid being 1/2 times the sum of the bases times the height, we just start plugging things in. The height technically is this distance from 2 to 10. So I'm going to put that at the end. And the two parallel sides are our bases. So evaluating the function at 2, half of 2 is 1. And at 10, half of 10 is 5. That gives us the two parallel bases. So we have 1/2 times 6 times 8 leaves us with 24. In part C, we're dealing with half of a circle. So we have a formula for that one as well. We do remember that the formula for the area of a circle is pi r squared. And we just want half of it, so we'll divide it by 2. Pi r squared over 2. We need to recognize what the radius is. And the radius of our circle is just the distance from the center over to the edge. We don't even need to mess with that formula at all. We could just, by inspection, see that the radius is 4. So, simplifying our expression, I got 16 pi over 2 is 8 pi. When it comes to this last one, y equals the square root of x on the interval from 0 to 16, we don't have a geometric formula for this type of shape. And maybe it looks like a circle, but it's not. We do know that this curve is like a sideways parabola. And we don't really have a formula for that. Any formula that we use would be really an estimate. So what we need to remember is that the fundamental theorem of calculus tells us that the area underneath the curve is the integral of the curve, square root x, dx, evaluated over the entire interval from 0 to 16. So we increase the power from 1/2 to 3/2, and then divide the coefficient by that 3/2, so we'll end up with 2/3, and evaluate this from 0 to 16. So 2/3 times 16 to the 3/2 minus 2/3 times 0 to the 3/2. Obviously this last term is going to be 0, but evaluating the first one, we got 2/3, 16 to the 3/2. Well, square root of 16 is 4, and we take that to the third power. That's going to make 64. Simplifying this expression, I get 128 over 3.